One more time, because y'all get me to repeat things 400 times. 72. I know 64, 66. Is that it? Don't be scared. Is that it? That's good. Okay. For real? 64. Here we go. 64 is x squared minus x minus 12 over x squared plus 5x plus 6. Folks, you have to be able to factor to do this. If you can't factor, you're going to have a horrible time with this. Okay? Now, factor the beginning or the top, the numerator. I know it's going to be x and x. I need two factors of 12 that when you subtract give you 1. 3 and 4. Signs are different. Which one's going to be minus the 4? And this is the tricky one. I bet I know what you did. You either did 6 and 1 or 2 and 3 or vice versa. You didn't, yeah. I need two factors. The 6 is tricky, and you really have to pay attention. I need two factors of 6 that when I add give me 5. That's your 2 and your 3. They're both going to be the same. They're going to both be pluses. Cancel out your factors. And for whatever reason, that is a very common mistake to get those wrong factors of 6. Always, always, always. You've got to pay real close attention and ask yourself that question every time. What two factors of 6 when I add give me 5? And when you say it that way, you know it's got to be the 2 and the 3. Okay? 66, let's look at that one. Oh, for real? All right, so here we go. We'll look at this, same thing, we're simplifying. We're going to factor. I need two factors of 18 that when I subtract give me 3. 6 and 3. The 6 will be minus, the 3 will be plus. I have a leading coefficient that is a prime number. I'm going to go ahead and I'm going to trial and error this one. You can slide and divide it. Either way, we should still factor it the same or get the same factors. I'm going to have 2y and y. And then I've got two factors of 3. Well, it's 3 and 1, but I need to add the 2 and the 3 to get 5. So if I put my 3 here and my 1 here, look what's going to happen. I'm going to have 2y plus 3y, which gives me 5y. Okay? Signs are the same, both going to be pluses. And that's just using trial and error. Yes, ma'am. Slide and divide. All right, we'll slide and divide over here. What I do is I take the leading coefficient and I multiply it to that last number, that constant. And I tie them together. I tie them together because I know I've got to go back and do something with it. I'm going to rewrite y squared plus 5y, just copying that straight down. 2 times 3 is what? 6. Plus 6. Now let's factor this. Here we go with the 6 again. I need two factors of 6 that when I add give me 5. 2 and 3. Watch. Let me move this over here. Go away. Go away. Go away. Thank you. Here we go. Signs are the same, both going to be pluses. I circled this for a reason. I know that I have to come back down here and now divide. I divide by that leading coefficient of 2. Now it's when I reduce and or rewrite. 2 over 2 becomes 1. Y plus 3 over 2 can't be simplified, so I now rewrite it. 2y plus 3. That's how you slide and divide. Does that make sense? Okay. You can YouTube factoring by slide and divide, and you can watch it over and over again. It is just a process that follows an algorithm that somebody figured out. If it's reducible, reduce it. What do you have to be real? What's the catch with slide and divide, though? What do you have to do first, if possible? You got to pull out that GCF. If you don't, it's going to mess up, and then you're going to be up the creek. Okay? All right, so let's go back. Can I cancel anything out? No. What? I did all that for nothing? Yep. But it's okay. It's simplified. That's all I can do. Does that help? Okay. Let's look what else is 67. Let's look at this one. 67. 2x cubed minus x squared minus 6x over 2x squared minus 7x plus 6. All right. What's the first thing we factor out always? GCF. What's the GCF of the numerator, folks? X times 2x squared minus x minus 6. And then what is up with that right there? Say I got a 2 as my leading coefficient. I've got a 6. Too much thinking for me. I'm going to slide and divide my denominator. And I'm going to write it over here. All right, Leslie, you ready? Here we go again. You tell me what to write. Uh-huh. Go. Both the same, both going to be minuses. Now what? Right on. Now what? Good. Good girl. Excellent. Now we're done. X minus 2 times 2x minus 3. All snot. What do I have to do in the numerator now? I got to factor this thing, that trinomial. I need to see if it can be factored. Okay? Numerator. 2x squared minus x minus 6. Same thing we've been doing. I'm going to slide and divide it. X squared minus x minus 12. What are my two factors of 12, folks? 3 and 4, because I want to subtract to get 1. 3, 4. My 4 is negative, 3 is positive. What do I do now? Divide it by 2. And what are my factors now, folks? 2x plus 3 and x minus 2. Right on. Okay. Does everybody see this? Because I don't think you can see it if you're looking at the back of your eyelids. Here we go. All right, 2x plus 3. X minus 2. From the numerator, and then x minus 2, 2x minus 3. Cross cancel what you can, x minus 2. Anything else? Will anything else factor? Cancel, cancel, cancel. Will anything else cancel out? Nope. Just leave it. X times that quantity over this quantity. I would just soon you leave it just like that, because it is in simplified form. Okay? Questions? Please ask. Folks, the first block said, what? How? You mean we one? Very good one. Folks, some of you do not like that number first. And when I'm going through these quizzes from yesterday, y'all are like, I'm not factoring in the way it is written. You got to. Look at it. It's still a difference of squares. Is 1 a perfect square? Yes. Is x squared a perfect square? Yes. Don't worry about it if it's not in the right order, okay? I'm still going to factor, what's the square root of 1? 1. What's the square root of x squared? X. The signs are different, right? And then what's up with that denominator? What do I do with that? What is it? It's a difference of cubes. That's good, whoever whispered it. Here we go. Cube root of x is x. Cube root of x cubed is x. Cube root of 1 is 1. This thing squared is what? X squared. This thing squared is 1. And how do I get that middle term? Multiply x times 1, which is x, or 1x. And this is subtract. Subtract. Just have to know the pattern of signs. Okay, you got to know it. Is there any, bless you, is there anything that we can cancel out that looks similar, that looks like, God, they're so similar, but they're not exactly the same? The 1 minus x and the x minus 1, right? Okay. Now, I would be able to cancel those out only after I do what? Factor out a negative 1. Folks, if you need to do this right here and make yourself a note, they're similar. They're not exactly the same. Factor out a negative 1 first. Then cancel out. These are the types of notes when you get your quiz back. It's not a case of wrong. Well, where did I go wrong? Wrong. Do it over. Not like my professor in college. I've got notes written all over your paper so you can kind of sort of figure out where you went wrong or what you did wrong. Okay? Here we go. I have to rewrite just because. I have to see it. 1 plus x. I'm going to factor out that negative 1. Now let's think. Negative 1 times what gives you positive 1? Let me say that again. Negative 1 times what gives you positive 1? Negative 1. Okay. Negative 1 times what gives you negative x? Plus x. Okay. We'll rewrite what we got. Can this trinomial be factored, yes or no? No, it cannot. Okay? Here we go. I am going to rewrite 1 plus x. Got my negative 1 there, and I'm going to rewrite x minus 1. Okay? All I did was rewrote this from here to here. All I did was just rewrite it. And then what can I do now? Cancel out my x minus 1s. I need it to be exactly the same. And when I write my answer, I'm going to throw my negative 1 out front. I can leave 1 plus x like that, or I can change it to x plus 1. Why could I change this one around and I don't have to factor out a negative 1? Because they're both positive. They're both positive. Anything else I can factor out? Cancel out? Am I done? Yeah, I'm done. How many of you got that problem right? Very good, y'all. Very, very good. Questions at all? Yes. Okay. I know what it is. When y'all have a trinomial, y'all don't like to have more than one variable in it, do you? Y'all don't like to have a variable at the tail end of this. That's what it is. All it is a perfect square trinomial. Here we go. You got to be able to look at this and say, hey, perfect square, the signs are the same. It might be a perfect square trinomial. Here we go. X and x. What are the two factors of y squared? Y and y. All right, now if you're not sure, still not sure what to do, let's go on and throw the signs in there. They're both the same. They're both going to be pluses. Let's check the middle term. X times x is x squared. X times y is xy. Y times x is xy. What's xy plus xy? 2xy. Did I factor it correctly? Yes. Okay, so my thinking's done for that one. What's x squared minus y squared? Everybody, how am I going to factor it? There we go. Thank you. Times, here we go, We got a leading coefficient. Don't freak out. It's prime. We got to figure out what we're going to do with the 1. 2x and x. Well, what are the only two factors of y squared? Y and y. Now we just have to figure out what? Where to put the sign. Where to put the negative. Where am I going to put it? It has to be at the end because 2x times y needs to be negative 2xy, doesn't it? So it's going to be here, and that's going to be plus positive. Everybody good with that? Do you understand why? Maybe? Maybe not. Maybe. That's a maybe, isn't it? Yeah. You understand? Do you not understand why? Okay. Here we go. Quick lesson. If this sign, if the second sign is a plus, that means that your factor signs will be the same. Okay? Whatever that sign is what they'll both be. Does that make sense? If the sign is negative, then these two signs will be different. Okay? Now, how do I know where the minus goes? Because when I check my middle term, 2x times negative y is negative 2y x. Y times x is positive xy. What's negative 2xy plus xy? Negative xy, which is what I'm trying to get right there. Okay? So I'm always thinking, how am I going to get that middle term to work out correctly? That's where I determine where my signs are going to go. Okay? All right, so look at the bottom, that denominator of that second term. What are the two factors of x squared, y'all? X and x. 2y squared, well, one's going to be 2y, the other one's going to be y. Where am I going to put my signs? Are my signs same or different, Tiffany? Right here. All right, now, I need my largest number, my largest product to be negative. So where's the negative going to go? Is it going to go here in the first set or here in the second set? Very good. Very good. You got it. You got this. All right. Am I done? No. All right, what do I start canceling out? Q, what do I cancel out? Pardon me? X, Y's? X plus Y's. Bless you. All right, and what's next? That's it? Oh, the X minus Y's. Okay. Is that it? Bless you. Ah! Bless you. Oh, I got another X plus Y. Oh, and I can cancel those 2's, can I? Seth, why not? Because they're different variables, you dumb tail. Can't do that, Miss Perry. Seth, that's what you told me with your eyes. No, dumb butt. You can't do that. Thanks. All right. Are we cool? Christian, did that help? Seriously? Okay. Really did? Really didn't. Really better had helped you. All right. No questions? Get up, move around just for a second. Ready, go. Excited because we're getting ready to add and multiply fractions, and I love fractions. Love them. Love them. They are fun. Fun, fun, fun. Hey, when we're adding and subtracting fractions, like today's the 9th, 1/2 plus 1/5, and yes, I want you to write that 4th grade problem down. I don't want us to just look at it. I know that's so difficult. Why is she making us do this? What do you have to have? Common denominators, okay? We must have common denominators. You got to. That's what you learned way back, y'all. Way back in the day. So if we were to apply, because y'all know I'm all about trying to make connections to our prior knowledge. If we had 1/2 and 1/5, what would our common denominator be? 10. Now, we know that. We all know that. But how do we get it? How do we get 10? We multiplied it. We multiplied them to each other, right? Because their only common factor that they have right now, their only common multiple is 1. Now, I want to ask you something. What did I multiply to 2 to get 10? And what we do to the bottom, we have to do to the top. So what's 1 times 5? 5. Okay, I get that. And then what did I multiply to the 5 to get to the 10? 2. What I do to the bottom, I have to do to the top, right? 1 times 2 is 2, which means our answer is 7/10. And of course, if we would have ended up with like 8/10, then I would have done what? I would have simplified or reduced it, and we would have been finished, right? Okay? We're going to do the same thing with all those letters, but we're going to approach it the same way. Okay? Again, this is just a review. Just a review from what we've been doing in the past. Here we go. And for a whole bunch of us, it's just a review from like a couple of months ago. 5 over x plus 3, yeah, minus, let's make that a plus. Let's make that a plus, okay? Both of my denominators are monomials, binomials, trinomials. They're both binomials. Why? How do you know that? 2 terms, okay? 2 terms means binomial. Now, that means if we have binomials, then in order for them to be exactly the same, they got to look exactly the same, right? So I want you to check this out. What's my common denominator going to be for those? It's going to be these 2. What did we do to the 2 and the 5? We multiplied them to each other. So what am I going to do to these? I'm going to multiply them to each other. Now, folks, I beg you, please don't skip steps in this. Just go on and write everything out. I can't read your mind, and it is very difficult for me to give you partial credit if you start skipping steps. Because when I'm grading 60, almost 70 papers, and I'm grading all the work, if you're at the tail end or if you're at the bottom of that pile, do you think I'm going to be as generous with you as I would have been early on? Probably not. Because I'm tired of grading 70 papers. Okay? That's not your fault, but I'm just telling you. Now, what did we multiply to this denominator? I've multiplied x minus 2. What I do to the bottom, I have to do to the top. And here's the thing. What do you think some people are going to forget? They'll forget the 5. They'll forget, oh, bring it down. Okay? What did I multiply to this second fraction? X plus 3. What I do to the bottom, I have to do to the top. Don't forget about the 2. Bring it down. What am I actually multiplying by? I'm actually multiplying by 1. Because if I multiply anything by 1, will it change its value? No. What can I add to any number that will never change its value? 0. If you know your properties, then you understand that and you grasp that concept very quickly. Now, what am I going to do here in this numerator? Look, that's the universal sign, isn't it? When you see me go, boom, boom, you know it's what property? Distributive property. Here we go. 5x minus 10 over that thing. Bear with me. I'm trying to keep you from writing everything. Plus, I'm going to distribute backwards. What's that going to give me? 2x plus 6 over that thing. The same thing. Now my denominators are the same, yes? What do I want to do? I want to combine like terms. I want to write this now as one numerator over one denominator. Just do this for your work, folks. I don't care what you do in your homework. Just at least write all these steps down for your notes, okay? And now what do I want to do? Combine like terms. Now I'm going to combine like terms. So 5x and 2x is what? 7x. Negative 10 plus 6 is negative 4 over this mess. Can I factor 7x minus 4? No. Am I done? Is this simplified as it can get? Yep, that's all she wrote right there. Done. Facile, difficile. Facile. Good. Good, good, good. All right, let's go on with another one. I want you to do this one. I should have started, dang it. 4 over n plus 1 minus 3 over m minus 2. This is when things can get a little tricky. Do they have anything in common, those denominators? Because it's a binomial and another binomial. They don't have anything in common. They're not exactly the same. So what will my common denominator be, folks? What will it be, Cindy? Multiply them together. M plus 1, m minus 2. And this is where I know that Gammons and we do things a little bit differently here. And it's all good. You keep doing it the way he showed you, that's fine. I'm going to show you the way I do it. We just approach it differently, okay? What did I multiply to the first denominator? M minus 2. So what do I have to multiply to the top? M minus 2. Got to bring down the 4. What did I multiply to the second denominator? M plus 1, so I have to multiply it to the top. M. Don't forget about the 3, okay? This is where we do things different. Y'all know I'm all about subtracting a quantity, and then I go and I distribute that negative 1, right? Mr. Gammons would have said, what do you need to do to that subtraction symbol? Change it to plus a negative number, right? You guys you will continue to do that as long as you do everything correctly and you don't make some little careless nonsense mistake. You're going to get to the same answer. I'm just going to approach it a little bit differently, okay? I'm totally okay with subtracting a quantity, okay? Bear with me. Distribute here, 4m minus 8 over that thing minus, distribute here, 3m plus 3 over that thing, right? Do I now have like denominators? Yes. I guess what I do is probably create an additional step, which I don't care. But I'm now going to write it as one numerator over one denominator. What do I have to do now? I've got to distribute that negative 1, okay? And I like detail, so this doesn't bother me because I know that that invisible 1 is there, so I'm going to distribute it now. And I'm going to have 4m minus 8. You fill in the rest. Tell me. Minus 3m minus 3 over that whole thing. And now we're going to combine like terms, and we're going to simplify if we can. 4m minus 3m is 1m, or plain old m. Negative 8 minus 3 is what? Negative 11, or minus 11 over this thing. Can I cross cancel out anything? Can't do anything with my m's? No. Morgan's like, no. No, you can't. Am I done? Done? Yeah. Questions at all? Again, I don't care how you deal with that subtraction. I'm going to deal with the subtraction my way. You deal with it your way as long as we get to the same answer in the end. That's all I care about. Okay? Does everybody understand what I did? Doesn't mean you have to do it, but do you at least understand what I'm doing? Yeah? Okay. Questions at all? Are we still in the land of facile? Yeah? Uh-oh. All right. Here we go. Check this one out. M over m squared minus m minus 20 plus 2 over m plus 4. What's going on with this one? I got to factor that denominator. That thing is mad. No, I can't deal with it. So I'm going to just come right up underneath it. How are you going to factor that? Give me 2 factors of 20 that when I subtract, give me negative 1. 5 and 4, signs are different. Which one gets a minus? That's right, 5. Good answer, guys. Way to go. Now look at the 2 denominators. I've got m minus 5, m plus 4, and then I got m plus 4 all by itself. How do I make them match? Because that's what I got to do. I got to make them match. Say it again. Be careful. Am I literally adding? I'm actually multiplying. I know what you mean. I know what you mean. But we actually have to, in order to make them match, then I want m minus 5 over on that right side. Hey, do I do anything to this rational expression on the left, yes or no? Did it really change? Did its value change? No, it's like taking a dollar bill and getting 4 quarters. It's the same value, just looks different, right? Yep, just breaking it down. Bring that m down. And then what did I multiply to that second one? Hey, finish the rest of it. You do the rest. I'm not going to say a word. All right, somebody talk me through this. Somebody I haven't heard from today. Let's go, let's go. Step up to the plate, folks. Go, Italian. Yep. Okay. And you do write it all again on your paper, don't you? You're going to do it all? You're going to write it as one fraction? Is that what you said? Or we're going to say, sorry. Is that right? Now what? Which are? Which is? Why? Why is this our answer? Because I can't do anything with the numerator. It's already simplified, right? How many of you had that? Hands up. Oh, love teaching trig. Y'all got it going on. Yes. Makes me happy. Questions? I don't guess so because y'all had your hands up. There we go. That's great. Okay, so let's look at this one. Last one. I just want you to look at the clock. Just look at the clock. This is the last one. Promise. Promise this is the last one. It's cool. Why is this cool? What's going on here? Tyler, what you thinking? You're saying, if I heard you correctly, I'm glad I'm not the only one who gets hiccups really loud. I feel your pain because I can rock the walls. Tyler, you're saying do this right here? Why? Why can I do that? What allows me to do that? You just know you can, right? Can't you put 1 under any whole number? Yeah, because again, we're changing the way it looks, but we're not changing its value. That's the power of 1, okay? So what do I do now then? Go ahead, Tyler. Say it again. You can cross cancel when you are multiplying and or dividing, but not when you're adding and subtracting. All right, so drop back. We're adding and subtracting fractions. What must I have? Say it again. What do I need when I'm adding and subtracting fractions? Common denominator. Somebody said it. I heard it. Go ahead, Seth. Got to have a common denominator. And I've got 1 and x plus 1, so what's my common denominator? X plus 1. All right. What did we multiply to that first denominator? X plus 1. So what do I have to multiply to the top? X plus 1. All right, now, this is weird because I'm bringing this x plus 1 down. This x plus 1 came from your denominator because, you know, we're really just multiplying by 1. What happens with this numerator over here? It stays the same, which is just plain old 1. Now, what am I going to do over here on the left? I'm going to FOIL it out. Here we go. X times x is x squared. X times 1 is 1x. 1 times x is 1x. 1 times 1 is 1. Right? Oh, you can go get water if you want to. It doesn't bother me, but you're welcome to go get water. All right, so what now? Come on, y'all, what now? Nuh-uh, say it, Chelsea, go. Don't be afraid. Yes, you are. Don't be afraid. Go. Say it. Say it. I got your back. Go. If I factor it, then I'm just going back to what I started with. So we begin chasing our tail. We don't want to do that. What do you mean? No. Again, we start chasing our tail. I don't want to do that. What do I need to do? Combine like terms. My like terms are right here in the middle, aren't they? So I want x squared plus 2x plus 1. Can I write this as one fraction now? So what do I have to tack on to the end? 1. Because I have common denominators, and once I have that, I can put it together, right? I got to combine like terms again. X squared plus 2x plus 2, and then are there 2 factors of 2 that when I add give me 2? No. What now? I'm done. I'm done. That's kind of an odd problem, but why do you think I would have given you a problem like that? Make you think, but what else? Think you're going to say it again. There's one on your homework like that. I want you to be prepared. I want you to know what to do. Okay? Do you have any questions at all? No? You ready for your homework? I told you I won't go lie to you. Here we go. Homework. Folks, I want you to look back at 534 because we got to work all those 115 problems. I want you to go with 80, 81, 83. It's telling you you're going to do it anyway. 87, 88, 91. Check this out. 80, 81, 83, 87, 88, 91. Yep. Seriously? Seriously? Is that it? Look at the clock. I just want to say, does this happen very often? No. No, it doesn't. Take advantage of it. Use your time wisely. Help each other. There is a right way to help and a wrong way to help. Let's use our noggin the right way. Okay?